All right, here is a problem about Doppler effect. This one is problem 43, again, chapter 16. This one says that a bat locates insects by emitting ultrasonic chirps and then listening for echoes from the box. Suppose a bat chirp has a frequency of 25 kilohertz. How fast would the bat have to fly and in what direction for you to just barely be able to hear the chirp at 20 kilohertz? So remember that humans can only hear a sound up to a frequency of 20 kilohertz, so that's why it's saying that for you to barely able to see it. So this is a Doppler effect because notice that the bat is the source of the waves, sound waves. The bat is emitting the sound at a particular frequency, but we know that the frequency that you hear, the observer hears, is going to be different because the bat is in motion. So this is a classic problem with Doppler effect. So you need to find in your formula sheet the equation that applies for Doppler effect. So here's the equation. It says that the frequency that the observer, O is for observer, the frequency that the observer hears is the velocity of the waves that we're dealing with, in this case sound waves, minus the velocity of the observer divided by the velocity of the waves minus the velocity of the source. Multiply all of this, multiply by the frequency at which the source emits the waves. So in this problem we have the bat is the source of the waves. So the bat is emitting sound waves at 25 kilohertz. That's called ultrasound. We have the observer that is going to be hearing this sound at 20 kilohertz. We have the velocity of the waves. We said this is sound waves, so the velocity at 20 Celsius is 343 meters per second. And the observer, in this case, the person, is not moving, so the observer velocity must be 0. The question of the problem is how fast would the bat have to fly and in what direction for you to barely hear the sound. So what we're looking for is the velocity of the source, the velocity of the bat. So we replace these numbers in the equation. So the frequency of the observer that the observer hears is 20 kilohertz. Velocity of the sound is 343. Velocity of the observer is 0. Divided by 343 minus the velocity of the source, in this case the bat, times 25 kilohertz. So we're trying to solve for Vs here. So the denominator of that fraction on the right-hand side, we're going to multiply on both sides of the equal sign by that. So 343 minus Vs ends up in the right-hand side. And we're dividing by 20 kilohertz. So we get 343 times 25 divided by 20, where we have canceled the units already. And solving for Vs, it would be 343 minus, and then you get 343 times 25 divided by 20, which gives you 428.75. So your final answer here is that the velocity of the source, that is the bat, is minus 85.75 meters per second. So the minus here, what does it mean? So remember that when this Doppler effect equation was discussed, we always have in Doppler effect a source and an observer. So the source, in this case the bat, is emitting sound. We have an observer somewhere, and the sign convention for the quantities for VO, the velocity of the observer, and the velocity of the source, was that the direction in which the waves move from the source to the observer is by definition the positive direction of velocities. So any velocity in the same direction is positive, any velocity in the opposite direction should count as negative. So the fact that we have a minus sign here indicates that the bat must be moving in this picture to the left or away from the observer, must be moving in the opposite direction in which the waves are arriving to the observer. So our final answer for this problem would be, rounding to two significant figures, would be 86 meters per second moving away from the observer. All right, that's it. See you in the next one.